It's very simple if we identify the concept and understand that very clearly. So this is the multiplication of any complex number. Now next, let us see the division. But the very important part is, before we go for division of any complex number, we must know the conjugate of a complex number. Let us see how a complex number is defined. Now complex number has its conjugate by means of the plus value or minus value of the imaginary sign changes its value. Therefore, if x plus iy is defined as the sign for the conjugate, for the imaginary value, we change the sign as minus. Similarly, if this value here is defined as minus, we change that as plus over here. So, and again, if z is the complex number defined to us, z bar is known as the conjugate of a complex number. Now, using this idea, if we look at this as an example, z equal to 2 plus 3i is the complex number, means its conjugate is 2 minus 3i. Take note, the sign of the imaginary value is changed. Similarly, if you take minus 5 minus 3i, then the minus 3 here for the imaginary changes. Please note, there will never be any changes for the real part. That's very, very important to know. Now, if we can understand the concept of the complex conjugate, now let us see how we can use that in a division. Now, as I said earlier, the division of a complex number is very, very important with the application of the conjugate of the complex number. Now, we apply the conjugate of the complex number only for the denominator. The denominator value is the one is focused when we are substituting to solve any problem. Let us see how the formula works first. Now, if this is the original question given to us, the denominator value is x2 plus iy2. Therefore, the conjugate of x2 plus iy2 is taken as x2 minus iy2. Similarly, in the denominator also I use the same value, because in mathematics, in order for us to multiply, we must balance the equation. So I multiply and divide both the values. So now when I simplify this, I find out that end of the day, the denominator now is without the I term. That's the reason why we take the conjugate of the denominator. So now, if this formula is applicable, let us see how an example works. Say this is a question that we have 3 plus 2i divided by 1 minus 3i. There is a complex number in the denominator. Therefore, in order to solve this problem or evaluate this expression, we look at the solution in this manner. 3 plus 2i divided by 1 minus 3i is the question. In order for us to solve, we got to say, take that value, multiply with its conjugate of the denominator. Take note, 1 minus 3i is the problem. The conjugate is 1 plus 3i. So I both multiply in the numerator and denominator. So when I simplify, I get the value as this, whereby you can see that plus 3i and minus 3i is a value that we can cancel off. Again, you can take note, I square is existing in both the values. Therefore, I square should be substituted with minus 1. Therefore, now you can see that this will become minus 6, which is here, and this will become minus 1. So minus times minus become plus after the cancellation. So now when we simplify further, we get this value, and now this should not be the final value, because the proper way of writing any complex number is the real part plus or minus the I times the imaginary part. Therefore, we can write the value of any complex number as the real part plus I imaginary part. Therefore, a standard form of a complex number is seen in any one of these. Now, with this we have seen that the definition of the complex number has led us to the power of I, how an addition, subtraction and also the multiplication division works. Always remember, in order for us to solve the problem of the division in complex number, we must use the conjugate. The proper way of solving the conjugate is by taking the imaginary value with the opposite sign and solve the problem. So this helps us to solve all the bottommost principle in complex number. Now with this we are finishing the first part of the complex number. So in the next session we will be solving the problems of the various types of complex number and how do we represent the complex number in Argand diagram and simplify using the concept.